Back in 2006, scientists from all over the world detected a poisonous gas in our atmosphere, methane gas. They noticed that the amount of methane in the atmosphere had suddenly shot up and was still rising. Methane is a type of natural gas that, when released into the atmosphere, traps heat around the Earth, kind of like how we wrap ourselves in a blanket to stay warm in winter. This gas acts like a blanket around the Earth, keeping the heat trapped inside and warming the ground even more. It traps more heat. Methane gas actually heats up the planet even more than regular carbon dioxide. In 2006, when its levels suddenly started rising, scientists thought it might be because of pollution caused by humans. But when they looked closer, what they found shocked everyone. It was a huge secret that our Earth had been hiding all along. So how is this methane gas being produced, and why is its amount constantly increasing? How does the scientific community detect methane gas? And most importantly, is this methane gas a sign that the world is heading towards its end? Is this a sign of something big, like a major climate shift? The scientific community already knew that methane spikes in the atmosphere usually happen once every 100,000 years. We figure this out by drilling into icy places like Antarctica and Greenland to pull out ice cores. Imagine that every year, about a meter of snow falls in Antarctica. The air from the atmosphere gets trapped in this snow, and then the next year, new snow falls on top of it. A new layer forms. When scientists do deep drilling and extract ice cores, these cores act like a time machine, holding records of the atmosphere from thousands or even millions of years ago. By studying them, they can figure out which gases were present in the atmosphere during different centuries and in what amounts. Using this method, the scientific community discovered that roughly every 100,000 years, there comes a point in Earth's history when methane gas levels in the atmosphere spike significantly. This signals that an ice age is ending and the Earth is warming up again. It's going to start getting warmer. When the ice age began to end, in just about 2,030 years, a lot of ice melted, and the Earth's climate became like what we have today. But here's the thing. Methane levels like that were recorded about 12,000 years ago, right before the Ice Age started to end. So why is methane rising in the atmosphere so quickly again now? Is our planet heading toward a big change, or is this some new kind of threat? To figure this out, we need to look at the Earth's history. Right now, we're in a phase of the Earth's timeline where it's called the Quaternary period. This period started around 2.5 million years ago and is still going on today. The Quaternary period is split into two parts. The first part was the Pleistocene epoch, which lasted from about 2.5 million years ago until around 12,000 years ago. During this time, the Earth went through repeated ice ages where large parts of the land were covered in ice. Then, after thousands of years, the ice would melt and most of the land would become ice-free again. This cycle of ice coming and going kept happening. This was also the time when humans started to evolve and big animals like the mammoth went extinct. And then came the second part of the Quaternary period is called the Holocene epoch. It started about 12,000 years ago and is still going on. During this time, the ice melted a lot, and the climate became much more stable and warmer. Because of this, humans learned how to farm. As glaciers melted, fresh water resources appeared, and people began settling near water sources. Now, here's a little confusion. We're in the Holocene, which is a warm period, but technically, we're still in an ice age. That means there's still ice at the poles. Yeah. It's just that those glaciers aren't as huge as they used to be at the peak of the Ice Age. We can only say the Ice Age is over when there's no ice left at the poles at all. But the question is, what exactly heats up the Earth and ends the Ice Age? The scientific community has identified three major factors called Milankovitch cycles. The first is eccentricity, which means the Earth's orbit around the Sun. Sometimes this orbit becomes a bit oval-shaped, and when the orbit is like this, at this point the heat we get from the Sun increases. This eccentricity cycle lasts for about 100,000 years. During these 100,000 years, the orbit changes from circular to oval and then back to circular again. But scientists believe that ending an ice age isn't just about the eccentricity cycle. The tilt of the Earth's axis plays a big role too. Basically, as the Earth orbits the Sun, it's tilted at about a 23.5-degree angle. But this tilt changes a bit over time. When the Earth is more tilted, the summers at the poles get warmer. There's more snowfall, and the snow melts quickly there. Scientists believe this cycle is also about 41,000 years long, during which the Earth's tilt changes from 22.1 degrees to 24.5 degrees. The third factor is precession, which means the Earth's axis wobbles a bit, like a spinning top. Because of this wobble, the timing of the seasons shifts. This cycle lasts roughly between 19,000 to 23,000 years. These three things, eccentricity, axial tilt, and precession, work together to start a cycle that warms the Earth. The snow melts because it receives maximum sunlight. It reflects sunlight, but when the white snow melts, the ground or ocean underneath gets exposed to the sun, and it's not white anymore, it's dark, like the color of soil or the dark blue of ocean water. Everyone knows that dark colors absorb sunlight way better. When more heat is absorbed, more snow melts, and this cycle keeps going. But the Earth really starts heating up when gases trapped in the ground, like carbon dioxide or methane, get released because of the heat. They start getting released into the atmosphere. These gases are trapped in the oceans or frozen underground in something called permafrost. When these gases escape, the ground heats up even more. So, the question is, if everything was fine, why was there such a big spike in methane in 2006? Especially since the event that ended the Ice Age happened just 12,000 years ago, not 100,000 years ago like it usually does. Around 1900, when the natural gas industry grew rapidly, methane emissions caused by humans also increased a lot. But by 1990, we hit a bit of a dead end at one point. So then, where did this new spike in 2006 actually come from? Methane is a gas that's produced not just by humans, but naturally as well. Like I mentioned earlier, there are gases trapped underground. These get caught in wet soil and oceans, and the melting of ice acts as a trigger for their release. Thanks to today's advanced technology, scientists can now figure out exactly where these gases are coming from. They use satellites to send a special wavelength laser beam down to the ground. This wavelength is absorbed only by methane gas. At these points, the laser light bounces back but doesn't reach the satellite, which means methane gas has absorbed it there. Using this method, the scientific community has created a global map of methane. NASA teams use this technology to map a 3-mile-long cloud of methane over a huge trash dump in Iran. It's releasing 73,440 tons of methane gas into the air every year. That's as much as the weight of 180 Boeing jumbo jets. Breaking it down by time, that's about 8,500 kilograms every hour, and that's just the beginning. Methane is coming out of Turkmenistan. There are 12 spots near oil and gas sites where around 400 kilos of methane is leaking into the atmosphere every hour. But scientists believe that the spike in methane since 2006 isn't just because of this. That accounts for less than half. A big part is being released from forests, especially those that used to be on permafrost. Now, since the permafrost is melting, fossils underground are decomposing fast and releasing methane gas. That's why a spike in methane gas is being observed. The biggest problem with methane gas is that once it gets into the air, it's really hard to collect. It's pretty easy to collect methane gas from landfills or gas fields, but the gas coming out of forests can't be collected at all. Even in many modern landfills, methane gas is captured and used to generate energy. The byproduct of this is carbon dioxide, which is definitely harmful but less dangerous than methane. In the atmosphere, methane gas lasts about 10 years. It can last for years, and then it turns into carbon dioxide and water vapor. The thing is, sure, methane levels like this have been detected on Earth before, like 12,000 years ago. But every time the ground has released this much methane, it was the end of an ice age. And now, with glaciers already melted a lot, we've never seen methane levels this high before. Maybe this is a sign that Earth is about to enter a whole new phase. But honestly, it's really hard to predict what's going to happen next. Is the ice age finally over, or are we heading into a new one? Because scientists don't really have a clear reference point in Earth's history showing methane levels have risen this much after 12,000 years, and we don't even know how high these levels will go. If this is happening naturally and not because of humans, then stopping it might be impossible. Hope you all like and share this video a lot, and keep those lovely comments coming. Thanks a lot. See you in the next awesome video.